Let me out of here, Mr. Flushable.
Not until you tell me the secrets of thermal energy, Bracoman.
You mean like the energy being released by this lava pit?
I guess so. You tell me.
Okay. If that's what you want, all you had to do is ask.
Great, so out with it. I really have to go, and this suit kind of chafes me, and I look like a hot mess.
Well, most of the time we think of thermal energy and heat as being the same thing, but they are really not. Heat is the flow of thermal energy from warm areas to cool areas. Like from the hot pit to the cool moon. In fact, that is the second law of thermodynamics. Thermal energy will always flow from hot to cold, unless work is done. On the other hand, thermal energy is the total kinetic and potential energy of the particles that make up matter.
So when you add up the kinetic energy and the potential energy you get the thermal energy? I thought that was mechanical energy.
Actually, they mean the same thing, only mechanical energy is talking about objects moving, and thermal energy is talking about heat moving.
Interesting.
It sure is getting hot in here, W. Hitch brings up temperature.
I already turned up the temperature.
No, you idiot, it dresses like an outhouse. The topic of temperature. Temperature measures the average kinetic energy of the atoms and molecules that make up matter. So that, if you increase the temperature of matter you also increase the thermal energy. Temperature is speed and speed determines kinetic energy, so kinetic energy goes up, so does the thermal energy. It's just basic math.
So, if I say, I have a temperature, what I'm really saying is that my molecules are moving.
Yes indeed. And your molecules will always be moving. Even when your molecules are not part of you anymore, because matter is made of constantly moving atoms and molecules, and we don't get new matter, it just moves around and recycles itself.
So if temperature affects thermal energy, what about a change in mass?
In the same way that temperature change affects thermal energy, with basic math we can show the relationship between mass and thermal energy. Mass determines potential energy, so if the mass, i.e. the potential energy, changes, so does the thermal energy even when there is no change in the temperature.
Like if Mr. Potts and Mr. Moore have the same temperature, 98.6 degrees Fahrenheit, but obviously Mr. Moore has more mass, so he would have more potential energy and therefore more thermal energy / mechanical energy.
Right on. Can I get out of here yet?
No. I've so much more to learn.
You can say that again. So how are you holding all that lava?
What do you mean? I just pumped it down there. It will stay, won't it?
Not unless this building is a good insulator. Otherwise it will just melt through.
Insulator, what is that?
An insulator does not allow heat to move through it easily.
You were kidding. I am out of here.
So now can I get out of here?
Sorry, no time. See ya.
Whatever.